When you think about a nuclear war, what's the first image that pops into your head? Probably a mushroom cloud, right? That blinding flash, the incredible, city-leveling blast wave. For decades, that's what we've all focused on. But what if I told you the deadliest part of a nuclear war isn't the bomb at all? So let's just get right into it. If a nuclear conflict were to break out, what would be the single most lethal consequence? You might think it's the radiation, poisoning the land for generations, or maybe the initial blast itself. But modern science is pointing to a different culprit, one that's honestly even more terrifying. That's right, smoke. It sounds almost unbelievable. How could smoke possibly be deadlier than a nuclear bomb? Well, it turns out that the smoke from the fires these bombs create could become a weapon in its own right, a weapon that threatens almost every single person on Earth, no matter where they are. To really get our heads around this, we need to dive into a concept that first came about during the peak of the Cold War. It's a theory called nuclear winter, and it completely changed how we think about the aftermath of a nuclear war. So here's the basic idea. When you detonate these weapons over cities, you don't just get a big explosion. You ignite these massive, uncontrollable firestorms. These fires then act like giant chimneys, pumping enormous amounts of smoke and soot way up into the atmosphere. That soot spreads around the entire planet, creating this shroud that literally blocks out the sun. And before you think, oh, that's just some old theory from the 80s, you need to know this. Recent studies using the exact same cutting-edge climate models we use to predict climate change have confirmed it. And what's more, they suggest the original scientists might have actually underestimated just how bad it could be. Okay, so let's zoom in on the real culprit here. It isn't just any old smoke. We're talking about a very specific kind of smoke, the kind that's full of black soot, from burning asphalt, plastics, roofing, all the stuff that our modern cities are made of. So here's how it plays out in 3 basic steps. First, the nuclear bombs ignite the firestorms. Second, those huge fires churn out incredible amounts of black soot. But it's this third step that's the real game changer. The intense heat from the firestorms acts like a rocket engine, punching that soot high up into the stratosphere. And once it's up there, above the clouds, there's no rain to wash it away. It just stays there for years. So how much soot are we really talking about? Well, get this. Even a limited regional war, say between India and Pakistan, is projected to create about 6.6 times trillion grams of soot. That's a mind-boggling amount from what many would consider a pretty small nuclear exchange. Now compare that to a full-scale war between, say, the US and Russia. The models show that could generate up to 180 times trillion grams of soot. That's almost 30 times more. The scale just becomes almost impossible to imagine. You might be thinking, well, couldn't they just avoid the cities and hit military bases? The problem is, most of the world's key military, economic, and political targets are right in the middle of, or very close to, major cities. So targeting them is targeting cities. You can't avoid it. And in doing so, you effectively turn our urban centers into the very fuel for a climate-ending weapon. Okay, so we've got all this soot circling the globe, high up in the stratosphere, blocking the sun. What happens next? Down here on the ground? Well, the result is a sudden, dramatic plunge in global temperatures, basically a man-made ice age. The impact on the climate would be absolutely catastrophic. We're not talking about a chilly winter. We're talking about a sudden drop in temperature that's bigger than anything in recorded history. A full-scale exchange could send temperatures plummeting to levels not seen since the last ice age. But instead of taking thousands of years, this would happen in just a few months. To really appreciate how powerful this cooling is, just look at this comparison. All the greenhouse gases we've put into the atmosphere since the Industrial Revolution, that's about a positive 2.5 watts per square meter. The huge Mount Pinatubo volcanic eruption in 1991, which cooled the entire planet, that was -4. The soot from just a regional nuclear war would have a cooling effect of -40. It's not even in the same league. And this deep freeze isn't something that just goes away quickly. Because that soot is trapped so high up, our best models now show it would stay there for at least 5 years, maybe even a decade, just continuing to block the sun and prolong the cold. And that duration, that's what leads to the real nightmare, the total collapse of agriculture. And the world's most important breadbaskets, places like the American Midwest or the fields of Ukraine, the freezing temperatures would pretty much eliminate the growing season entirely, for years on end. You just can't grow crops when it's freezing.
And if you can't grow food on a global scale, that leads to one horrifyingly inevitable outcome: the collapse of the world's food supply and a famine on a scale humanity has never, ever seen. The latest studies project that in the aftermath of a major nuclear exchange, as many as 6.7 billion people could starve to death. That's most of the people on this planet. It's a number that just completely dwarfs the number of people killed in the initial blasts.
For anyone lucky or unlucky enough to survive the initial attacks, life becomes this brutal gauntlet. The first day is about surviving the blast and the fire. The first weeks are about radiation sickness from the fallout. But the months and years that come after, that would be a slow, grinding battle against malnutrition, starvation, and the diseases that always follow. And here's the crucial thing to understand. Your country doesn't have to be hit by a single bomb to be completely devastated. The climate effects are global. A farmer in Argentina, thousands of miles from any explosion, would watch their crops fail all the same. In a nuclear winter, there are no bystanders. Everyone is at risk. So this all leads to the obvious question, right? Is there anywhere to go, anywhere on Earth you could actually be safe and survive this? Well, some research suggests a handful of nations might be able to weather the storm better than others. Generally, they're countries in the southern hemisphere, far away from the likely conflict zones, with strong enough agriculture to maybe feed their own people. But let's be honest, for the billions of us living everywhere else, that's not much of a comfort. And this really brings us to the most important point of all. The reason we study the science of nuclear winter isn't to find some bunker to hide in. It's about prevention. As the former Soviet leader Mikhail Gorbachev said, it was this very knowledge that spurred leaders to act, to de-escalate, to pull back from the brink. The purpose of this terrifying science isn't to paralyze us with fear. It's to show us the true global stakes of these weapons, leaving us all with one final critical question. Now that we know, what are we going to do about it?